Hi Chemistry, this is Mrs. KJ and I'm going to go over the 3.01 properties of acids and bases. Concentrated hydrochloric acid is dangerous. If you spill it on your skin, it can cause an acid burn. And just so that you know, an acid burn, it's not actual burning like with fire, but it feels like a burn and it can continue to burn even after you wash it off for quite some time. So it's a very, very serious thing. And yet, more than 20 million tons a year are produced worldwide. It is used for thousands of industrial purposes. Concentrated lime, a base, can also cause harm to skin, and yet more than 50 million tons were made in 2007. Acids and bases have a profound impact on all of our lives. In this unit, you will study their properties. Lesson 1, Properties of Acids and Bases. Acids and bases are solutions that have special properties. Acids and bases have many uses in the world around you. You are most likely familiar with several examples: battery acid, lye, vinegar, but have you thought about what characterizes an acid or a base? This lesson will focus on the properties and characteristics of many common acids and bases. Goals for the lesson: describe the observable properties of acids, describe the observable properties of bases, give examples of some common acids and bases, describe the observable properties of salt solutions. So solutions. Some can be classified as acids, which are sour, reactive with metals, sometimes caustic. Solutions. Some can be classified as bases, which are bitter, not reactive with metals, and slippery. Again, you can use the student guide in order to help with your notes. I copy pasted the beginning, which is what we just read, and it also included the unit objectives, so I wanted to make sure to read those. Describe the properties of acids and bases. Know the Arrhenius, Bronsted-Lowry, and Lewis acid and base definitions. Define pH with regard to hydrogen ion concentration. Use pH to describe the acidity or alkalinity of substances. And then it also has the keywords and pronunciations. Acids, a substance that is characterized by a sour taste and has a pH of less than 7. Base, substance that is characterized by a bitter taste, slippery feel, and a pH of greater than 7. And neutralization, a reaction between an acid and a base that produces water and salt. And I'm going to change that to a salt because you might remember from earlier in the year. We talked about how NaCl is table salt and the salt that we're used to talking about, but other things such as KCl can also be salts. Salts are basically leftover precipitates from a double displacement reaction, or in this case from a neutralization. So it can be many different things, not just table salt. Under the lemons, the properties of acid and base solutions are familiar because most people use these solutions daily. Acids and bases are part of our everyday lives. Acids and bases are common in the everyday world. For example, if you were to bite into a sour pickle, you would probably feel your lips pucker up. This reaction is caused by an acid. At some point, you no doubt had a bar of soap slip out of your hands. While sour taste is a property of acidic solutions, slipperiness is a property of basic solutions, also called alkaline solutions. So alkaline solutions means the same as basic. And I think sometimes they use alkaline more because basic, can also sound like something that's simple instead of just that it's made out of a base. So I added to our notes alkaline solutions, a solution that is a base, or in other words, basic. Acids have unique properties. The word acid comes from the Latin word acidus, meaning sour. Acids, when dissolved in water, have a sour taste. While it is true that you should never eat or drink in a laboratory setting, chances are good that you have already ingested some acids today. Oranges and grapefruit, for example, contain citric acid. Milk and yogurt contain lactic acid. If you have had seltzer or soda lately, you have taken in carbonic acid. And vinegar contains acetic acid. You may have also experienced the feelings and sensations these acids can cause. Have you ever had a small cut on your hand and then squeezed a lemon or lime? If so, you know that citric acid stings. The examples here show that many acids are common and cause only minor irritations. Milk contains lactic acid, the same acid that makes muscles sore after exercise. Some acids are quite dangerous. Industrial strength acids are manufactured in large factories or plants. For example, nitric acid, HNO3, is made by processing ammonia. It is used in fertilizers and in the manufacture of explosives. Nitric acid is an oxidizing agent and turns whatever it is in contact with, including your skin, yellow. Burns caused by nitric acid can be very serious. Sulfuric acid, H2SO4, is another acid with industrial applications. It is used in fertilizers, in water treatment facilities, and in batteries. Sulfuric acid is also a main component of acid rain. Acids react with metal. For example, if an acid were poured onto a strip of magnesium metal, the two would react to form hydrogen gas. This property can be used to identify acids. Magnesium as a metal reacts vigorously in nitric acid. So even though it's a still picture, you can see the bubbles, the gas given off, the color change. This is a pretty intense reaction. Acids occur in the biological world as well. You may not realize it, but your stomach contains a powerful acid. The acids in your stomach include hydrochloric acid, HCl, which that's a lowercase l, not an I, so HCl, which helps break down the food you eat. At times, some people experience acid reflux, a condition that occurs when the acids in your stomach backtrack into your esophagus. This phenomenon may be treated with medications to decrease the production of acids or to neutralize it. Many animals use acids as a defense. The giant petrel, a bird, may defend itself by spitting partially eaten food at its enemies. This food contains stomach acid from the bird, and that acid stings the enemy. Several types of sea slugs secrete sulfuric acid, H2SO4, which makes the slugs taste bad and protects them from predators. Certain species of ants have the abilities to sting as a defense. The stinging power results from formic acid, HCOOH. The sting of an ant or bee feels similar to the burn of lemon juice in a wound. Both are the results of acids on the skin. So I just added under acids, number 1, examples include vinegar, lemons, industrial acids, HCl, in your stomach, ant stings. Acids react with metal and produce hydrogen gas. Acids can be caustic, and caustic simply means that it can burn the skin. Bases have many of their own properties. Bases have a bitter taste. You may have, at some point, tasted soap or a soap bubble. Soap solutions are bases and will taste slightly bitter. Milk of magnesia, MgOH in parentheses 2, and stomach antacids are also bases. These products are typically used to fight heartburn or acid reflux. Bases have a slippery or greasy feel. Soap is probably the best example of how a base feels. Care must be taken with bases, however. If your skin comes in contact with bases for an extended period of time, burns can result. If you forget to wash soap off of your skin after a shower, your skin will redden as the base affects your skin cells. The bubble is intriguing and has properties that are different from an acid. Bases are found in many products. Many of the caustic cleaners used in homes are composed of bases. So caustic means that it can burn the skin. Both an acid and a base can be caustic. For example, oven cleaners and drain cleaners are typically composed of sodium hydroxide, NaOH, a base. Other cleaning products contain an ammonium solution, NH3. Bases are typically quite hazardous and should be used with caution. Ammonia is a base that is found in urine. In fact, splunkers and others who visit caves may find that the concentration of this base in the cave may be overpowering. Bat guano, which is feces, and urine contain ammonia and can cause the eyes to water and may impede breathing. Most strong cleaning products are solutions of bases. Acids can be used for milder cleaning purposes. Take one last look at the properties of acids and bases. Acids and bases have very different properties. This table highlights the major properties and some examples of each. So taste. Acids are sour. Bases are bitter. Feel. They can burn. They can also burn for bases, but they also feel slippery. Acids react with metals. Bases do not react with metals. Examples, citric acid from fruits, hydrochloric acids in your stomach, acetic acid, sulfuric acid. Examples of bases, sodium hydroxide, drain cleaner, ammonia, cleaners, and excretions. Acids and bases have definite contrasting properties. And so I added to the notes for bases, examples, soap, antacids, ammonia, strong cleaners, and bases can also be caustic. And again, caustic means it can burn the skin. When mixed together, acids and bases form salts. Suppose you were to mix an acid and a base. They would react quickly and water plus a new substance would form. Okay, so let's pause there. Think about if you put vinegar and baking soda together. Which one is the acid? the vinegar. What happens when you put baking soda and vinegar together? They bubble. And what's left over is actually water and a new substance which we would call a salt. This product would not share any properties of either the reactant acid or base. You might say the properties of the base and the acid have been neutralized. Another way to say this is that the acids and base have undergone a neutralization reaction. In any neutralization reaction, the result is water and a salt. The properties of acids or bases can be neutralized when they are combined. Water and a salt are the result. So we have NaOH, which is our base. We have chlorine and hydrogen, so hydrochloric acid. Put them all together, we get water plus NaCl. In this case, the salt that is created is table salt. So I just added this to our definition. Another way to say this is that the acids and bases have undergone a neutralization reaction. And note, the salt can be NaCl, table salt, or other compounds. Salts can be many different types of ionic compounds. The salts that form from neutralization reactions are typically ionic crystalline solids. They have high melting points and usually dissolve in water. Salts are good conductors of electricity. For example, if the acid HCl, or hydrochloric acid, is mixed with the base sodium hydroxide, which may result in an explosive reaction, a salt forms. HCl plus NaOH yields table salt plus water. This is common table salt. Another example, H2SO4 mixed with potassium hydroxide brings about this reaction. H2SO4 plus potassium hydroxide yields K2SO4 plus water. The potassium sulfate is the salt this time. So this is our salt because the other thing is obviously water. The salt potassium sulfate, a common ingredient in fertilizer, is produced. Salts exhibit interesting properties of their own and are used for many food-related applications. So we have table salt, NaCl, enhances flavors and aids in storage of food. Potassium sulfate is for fertilizer. Magnesium sulfate is a drying agent used to absorb excess water. Potassium bitartrate is a stabilizer for egg whites, prevents sugar syrups from crystallizing, and reduces discoloration of boiled vegetables. And I just copied from the slide by underlining the key points. Typically, ionic crystalline solids are our salts. They have a high melting point and usually dissolve in water, and salts are good conductors of electricity. And then, of course, I gave an example of a reaction that will produce a salt and water. Acids and bases have their own unique characteristics. Acids and bases are very different types of compounds. Acids tend to be sour in taste, are not slippery, and react with metals to form a gas, specifically hydrogen gas. Bases are slippery to the touch and bitter to taste. Bases are quite caustic, they can burn the skin, and are used in materials such as drain cleaners. When mixed, acids and bases undergo a neutralization reaction to form water and a salt. Solutions can be classified as acids, which are sour, reactive with metals, sometimes caustic. Solutions can be classified as bases, which are bitter, slippery, and not reactive with metals. And that is it for this lesson.